For these problems, we are going to find horizontal asymptotes, if any. Now, it's the same procedure for finding a horizontal asymptote on all of these rational functions. You start by comparing the degree of the numerator to the degree of the denominator. And I'm going to abbreviate that DEGNUM for degree of numerator and DEN for denominator. Now, what is the degree? The degree is the highest power of x. So in this first numerator, there are no x's. So my highest power of x is 0. I can also think of that as, remember, x to the 0, something to the 0th power is 1. So this is like 6 times a hidden x to the 0, and the highest power of x is 0. Now in the denominator, I've got a power of 1 for the x and a power of 3. The degree is the higher power, which is 3. Now in this situation, let me write it here, what we've come up with is that the degree of the denominator is larger than the degree of the numerator. When the degree of the denominator is larger than the degree of the numerator, you always have a horizontal asymptote at y equals 0. Doesn't matter what these numbers are, as long as the denominator degree is larger, the horizontal asymptote is y equals 0, which is the same thing as the x-axis. Make sure you include the y equal. The horizontal asymptote is not a number, it's a line, a horizontal line at y equals 0. Okay, now the second one, again, I'm going to do the same thing, compare the degrees. So the degree of the numerator and the degree of the denominator. 17 doesn't have any x's, so that has an x to the 0, but here I have an x to the 5th. So the degree of the numerator is 5, since that's the highest power of the numerator. And similarly in the denominator, the higher power of x is 5. Okay, now the key thing here, and I'm going to write it, you don't necessarily have to do this part. For your work, I would recommend that you write down degree numerator, degree denominator, and what those degrees are so that I know what it is that you're looking at. But the key element here is that the degrees are equal. When the degrees are equal, the horizontal asymptote is the ratio of the leading coefficients. Now what does that mean? Leading coefficient is the number in front of x to this power, including any signs. So in the numerator, I've got 17 minus 4x to the 5th. The number in front of x to the 5th is a negative 4. Now I also need to divide that by the leading coefficient of the denominator. In the denominator, the number in front of x to the 5th is a positive 2. So the horizontal asymptote is at y equal the ratio, and I can even highlight it here, of negative 4 over 2, which of course reduces to be negative 2. And once again, make sure you put y equal negative 2. Don't just put the number. Okay, so here's what happens when the degree of the denominator is larger. Here's what happens when the degrees are equal. And you can probably guess what's going to happen with this one. The degree of the numerator in this situation is 2 because we have an x squared. The degree of the denominator is 1 because there's no power written, so it's understood to be x to the first. So now we have where the degree of the numerator is larger. In this situation where the degree of the numerator is larger than the degree of the denominator, there is no horizontal asymptote. What would actually happen is we get what's called an oblique or a slant asymptote, but we're only asked to find horizontal asymptotes, and there is no horizontal asymptote when the degree of the numerator is larger than the degree of the denominator.